Hey guys, today we are looking at one of our similar triangle shortcuts, just like we had shortcuts with our congruent figures where we only had to name a few things to be able to prove that triangles were congruent. We have those as well with similar triangles. And so the first one we're looking at, as you can tell by the title of this, is angle-angle. So our angle-angle similarity postulate is the first thing we're talking about. So if two angles of one triangle are congruent to two angles of another triangle, then we have enough information to say that the two triangles are similar. So this says determine whether the triangles are similar. If they are, write a similarity statement. So thinking back to our last lesson and what a similarity statement is, we're going to have to use that here. So we just need to get to two angles matching. So in the first one, I see these right angles. So we're off to a good start. Angle B is congruent to angle E. And then I have a 68-degree angle and I have a 22-degree angle. Well, if you think back, we said all of our angles have to add up to 180, but if we have a right triangle, then the other angles just have to add up to 90. So what we need to see is if I do 90 minus 68, that should give me angle A. So if I do 90 minus 68, we get 22 degrees. Which means that angle A is congruent to angle D. So we've shown enough then that we can say that yes, they are similar in triangle A, B, C is similar to triangle D, E, F. That's our similarity statement. Okay, and then example B. We have, I see right away, angle R is congruent to angle F. Those two match up. And then I need to look and see. So then all three angles should add up to 180. We don't have a special case here with a right angle. So I'm going to look at the triangle on the left, and I'm going to do 71 plus 78. So that should give me 149 degrees. So if that's 149, then I can do 180 minus 149, and so when I take that away, I get 31 degrees. So that means that angle Q down here is 31 degrees. So then angle Q is congruent to angle G. Now you want to be careful because these triangles are flipped around. So we're going to say that yes, they're similar because we found two angles that were congruent. And then we say triangle PQR. So I started with angle P, which should match up then with angle H, is similar to triangle H. Since it's the 71 degree, we don't have that. Then Q is 31 and G is 31. And then R is 78 and F is 78. So it didn't go in quite the order that we thought it would. It's not in alphabetical order for both of them. So make sure you're paying careful attention to that. All right, then example C. We're going to do that same type of thing because I see that angle P is congruent to angle H. So the 27 and 27 match up. So I'm going to take care of this top triangle and try to find angle Q. So 27 plus 53. So 27 plus 53 gives me 80 degrees. And then I'm going to do 180 minus 80, and I get 100 degrees. So angle Q is 100 degrees. So as I'm looking at the two triangles, it looks like angle G is 110 degrees. So these triangles are not similar. That's all we have to do there, because we can't write a similarity statement if they're not similar. So let's try a proof. So we have given that we have two triangles, triangle RQS and triangle RTV, the measure of angle RTV is 49 degrees, and the measure of angle RQS is 49 degrees. So those are both given. We want to prove that triangle RQS is similar to triangle RTV. Okay, so our reason on number 2 is reflexive property. And think back to our reflexive property, and that means that something is congruent to itself. So the only information we have so far is about two different angles. So we're not using the given statement just yet. But I do see, if I look in the picture up here, that angle R is congruent to itself. We need to be careful because while angle R is the same angle, I don't want to say angle R is congruent to angle R. I'm going to be a little more specific here. So I'm going to say angle R in the smaller triangle. So if I'm tracing the smaller triangle, that would be angle TRV is congruent to angle, and then I'm going to the bigger triangle, so QRS by the reflexive property. Now, we have that the measure of angle RTV is equal to the measure of angle RQS. So we've taken these two statements from the top, it looks like, and we've just combined them together and taken out the 49. So when we do that, that's the substitution property. So substitution property of, and I'm looking and I see an equal sign, so property of equality. Now, definition of congruent angles. We've talked about anytime you see that definition of congruent angles, we should immediately know that we need to switch it over from equals to congruence. So I'm going to take the measures away and say that angle RTV is congruent to angle RQS. So by definition of congruent angles, they're equal, they're congruent. So at that point, I can put double arcs there on those two. So now I see in those two triangles, I have two pairs of angles that are congruent to each other. Therefore, the triangles are similar by angle, angle, and I'm going to put our similarity squiggle there to show similarity. All right, one last problem. We're going to talk about a lifeguard at the beach. So the lifeguard is standing next to his chair. He's casting a shadow, and the chair is also casting a shadow. We want to know how tall the chair is. So I look and I see by angle, angle. See these two arcs there, and then the right angles. Those two triangles are similar. So I know that I can set up that proportion to solve for that missing side. But the issue I also see is that we're not working in the same units here. I think it's probably easier to move everything over to inches since we have 48 inches here. So 6 feet. I know that there are 12 inches in 1 foot, so 12 times 6 would make this 72 inches. And then 6'4", well, if 6 feet is 72 inches, 4 inches more would make this 76 inches. So when I go ahead and set this up, I'm going to set it up as the matching corresponding pieces of the triangle in a ratio. So 76 is the stand up of the lifeguard. That's the vertical of the lifeguard. The vertical on the chair, we don't know. It's called X. The horizontal on the lifeguard is 48. And the horizontal on the chair, the shadow lengths, is 72. So from there, we're ready to cross multiply. So when I cross multiply, I get 48 times X equals, and I have 76 times 72. So 76 times 72 is 5,472. I'm going to divide both sides by 48. So then x equals 5,472 divided by 48 is 114. But my label here is going to be in inches since everything else was in inches. So if I want to get it back to feet, I need to divide that by 12. So 114 divided by 12 would give us 9.5. So that's 9.5 feet. Be careful if you wanted to change that over. 0.5 feet isn't 5 inches. Half of a foot would be 6 inches. So 9 feet, 6 inches. Either one of those answers would be okay. So the height of the chair is 9.5 feet. All right, guys. I will see you in class. If you have questions, please come see me. Have a great day.